Everyone's enjoying the second day of the conference. Welcome to the session on agricultural stressors on environmental health. We have four speakers here today. So we'll get started with our first speaker, Dr. Martha Gehrig.
Hi there, and thanks for joining us after lunch. I'm excited to start off this session with a little bit of an unexpected presentation. I was hoping when I put this abstract in that I'd have a nice suite of analytical lab data. I have zero. So welcome to this part of the presentation, with unforeseen lab backups. And then with the funding mechanism of this project, everything's a bit on hold with how we are funded. So I will go ahead and just talk through the methods and the impetus and look forward to chatting about it in the question session. So today I'll be talking about our attempt at determining the effect of drone applications of biostimulants on nutrient management in the agricultural Midwest. And this study is done in Missouri, where Waterborne has a large field office, but I'm a remote employee now in Milwaukee, Wisconsin. So I'll just throw you all over the map here. All right, so we are attempting to connect these two novel agricultural practices, biostimulants and the drone application of them. So I'll use the term biostimulant throughout this presentation, but a lot of folks refer to them as biologicals or biological crop protection products. It's something that our commodity groups throughout the Midwestern states are asking about. Is it worth the money? Does it do what they say and they promise? So we're trying to dig into that here. And the whole thought of this is that biologicals are sort of a counterpoint or a help for their synthetic fertilizer counterparts. So what they do is they are inoculants that host microbial communities that are intending to strengthen the soil's symbiotic relationship with the plant. So one of the guys who helps advise us here says that we're treating the system, not a plant, not the soil necessarily, but we are treating the relationship of the plant with the soil. So I try to keep that in mind too. And this is all to stimulate plant nutrient uptake, early crop growth in that vulnerable early stage, and then stand quality. And for the purposes of our interest, we like the thought that it can decrease fertilizer use. It can substitute your synthetic fertilizer regimen or act as an amplifier for that, but you can reduce, in theory, your fertilizer use. So that's sort of our perspective on it. The state of Missouri is interested in drones and the usage in agricultural practices in multiple different ways. So it can be used for both crop monitoring, so the visual estimates of how your crop is proceeding throughout the growing season, as well as in precision ag, you'll often hear that, but also the actual physical application of crop protection products. So we actually do both in this project. And due to their compact size and maneuverability, it provides this nice combination of high spatial resolution of images or of spraying and fast turnaround capability that maybe isn't offered with your conventional sprayers or even contracted full-size aircraft. So we like the thought of that, and producers like the thought of that as well, reducing some costs on an annual basis. We like the thought that it can reduce soil compaction and offers producers the flexibility of application. And I say late season here, but throughout the growing season, whenever you want to tackle a problem area in your field. So that's sort of the impetus of where we approached this study. So the way that we put it together was a comparative field study that layers these two unique conservation practices. And as this is an NRCS funded project, I always try to keep in mind what are our producers really wanting to know. And so we're looking at increased soil health, reduced nutrient loss, and the way that we measure that is via water quality, enhanced plant uptake. And then we look at the crop progression and yields on a typical Missouri farm. And you can see this is a drone image, and our water quality instrumentation is over on that upper right-hand side of the figure. But I'll show you that more in depth here. So the benefits that we tried to target in this study are threefold. The flexibility in the timing of your application and the method of doing so. The drone offers that. And the precision in the use of products. You often think of overspray or drift and how we can kind of tackle that by using drone and the person hours that are required to do that. And then looking at the cost effectiveness over the equipment lifespan. These drones are not cheap, but how they compare with a conventional sprayer and looking at those capital costs as you're trying to break down what these things look like on an annual basis. So we are doing this project in partnership with the Missouri Soybean Association. Any photos that you see in the field are taken on their land at the Bay Research Farm in Columbia, Missouri, smack dab in the middle of the state near the university. And then we are also working with a biological manufacturer called Biodyne USA, and they are folks who are helping us with the actual application and sort of holding our hands with what is expected and how they look at their own trials as well. And then we have an independent drone operator who uses drones on his farm. He thought of doing it for a job and then one day said, I'm going to buy my own drones and see how this works. And at $50,000 a pop, he made up his own contracted aerial spraying in 1 year. So that capital cost really paid out for him in that 1 year alone. And now he's doing it for the whole county. So I'll have you take a look at my juvenile schematic here. We were hoping to have a nice well-crossed study, but as we know, these things fall through when we're trying to find real fields to try and capture this type of data. So we had 4 fields available to us, 2 of which were nicely positioned and sloped that we could get water quality data off of them. So that's field 1 and field 2. And instead of being able to really parse apart the drone and biological effect, they're layered, and then we have replicate fields. So we have 2 control fields, 2 treatment fields. So bear with me as I try to parse that out, and I'll catch you in the next year when I actually have some data and we can talk about it then. But for field 1 and 2, we get that water quality data, but then we take soil health parameters and plant tissue samples across all 4 fields. And I'll talk a little bit about how that's managed. And then we have weather stations that are getting at that air temperature, precipitation, those factors that really impact our runoff and crop progression as we see it. So I'll give you an unhelpful figure here, but I just wanted to show, I sat in on the networking session yesterday about how do we parse apart management or the effective management decisions through monitoring data. And I think what we came up with is there are a lot of parameters and how do you really parse apart the signal. So here I have fields of differing size. I have different crop rotations that will turn over in a year. I have water quality on some, but not all. I have variable rate fertilizer that's coming through, and then the impact of reducing the rate on those fields where we have biostimulants being added. So this is all to say, and all of you know this in this room, is we're just trying to figure out how to compartmentalize these factors as we do start to receive our analytical lab data. So the first thing we did is I call it our little drone. It's our visual drone, not the one that's spraying. We send that up and we are taking visual surveys of these fields, mainly to get at to delineate our little infield watershed. So it's great that we had the whole field to work with, but we know that there are actually sub-watersheds, so to speak, within each of these fields. So we had to delineate that right off from the bat by building a digital elevation model and looking at those flow lines. And what you could see them visually, but of course we wanted to confirm that. So that's what field 1 and 2 look like. Those are our water quality fields. And you can see that they are in the 3.5 to 5 acre range. So relatively small, but I'll go ahead and make them smaller on field 3 and 4, where we're looking in the 1 to 1.5 acre. And again, we're doing plant and soil metrics on all of these, but we're really working with what we had with our partnerships and trying to establish a strong partnership working or moving forward. So, as all best laid plans are, when we pitched this project, we thought it would be on fields that were underlain by tile. They had two fields side by side, perfect setup to get tile drainage data. Well, 2023 was a pretty darn dry year, and they didn't realize that in the interim, those tiles had failed. So we pivoted on a dime, and we went from capturing subsurface flow via tile drainage to overland flow via runoff. And we installed these instrumentation to capture that. So we installed flumes. You can see the white are our flumes and wing walls at those natural flow points or outfall points, and to really capture flow during those qualifying rain events. And we're doing this under a pre-post application. While we'd love to have a year of pre-data, in 2024, we have 2 composite samples of pre-data and 9 composite samples of post-data. And we will replicate this for the years of this study. These systems are set up with ultrasonic sensors to trigger an ISCO auto sampler to start taking samples during a qualifying event. And then when we do get those composite samples, we try to get the greatest perspective. So all those promises that biostimulants made, there are a lot of different perspectives. We're talking about a lot of nutrient species. So we're going at nitrate, ammonia, TKN, total phosphorus, which is interesting because that's where we reduced our synthetic fertilizer, was in the phosphorus range, and total dissolved solids and total organic carbon. So a full suite here for what our budget allowed. And then where I think the proof will be in the pudding is really in these soil and plant samples. So again, I'm giving you this table just to show that we tried to capture plant and soil samples at these critical growth stages throughout the growing season to ensure that we are capturing at times when plants need more nutrients than less, and will give us hopefully where we can parse out that biostimulant impact if it's doing what it says it's doing. So while I don't have any data to show you, I did take a little clip of what a sample output would look like. And while usually we contract directly with a lab, we tried something different, and we're going with a lab and then a third-party service who helps with interpretation. So when we bring this back to the NRCS or to producers, we can say this is interesting in the notion that somebody has already sort of interpreted this for you. And I think that's a novel. I'm not an agronomist nor a farmer, so being able to understand these in sort of terms that are useful for management decisions is an exciting way forward. So I did want to pick out just 2 parameters here: water extractable organic carbon. So that's the partition of the organic carbon that is, most readily available to those microbes. Again, biostimulants are microbially based, so those are the parameters I'm thinking of. And it may reflect the quality of the organic matter in soil, and we understand that this would fluctuate throughout the growing season, freeze-thaw events, and then the presence of residue material that's sitting on field after harvest. And then the second parameter I wanted to look at was the Haney test. So that soil respiration, or the production of carbon dioxide over a 24-hour incubation period. And this is sort of relating to, the breadth of the soil in simplistic terms, but the soil's potential to host microbial activity. And so in this example, you see the low at that 38.4 ppm. That may exhibit slow residue breakdown. So your corn stubble that's sitting on, that might be slower than perhaps you may want. And that example score indicates that there is some potential for nutrient cycling. The microbes are working, but residue management may be an issue with prolonged use of these high carbon crops. So that's the sort of, management implications that this data is trying to get at. And the people that we are partnering with, those are the management decisions that they're trying to help folks with. So that was the soil. And then this is the plant readout, actually. So you can see sort of the optimal is that green in the center, and you have your macro and micronutrients and where you kind of sit on that slider. Again, this is example data. But what I think is interesting are these 8 different factors at the bottom that give you, sort of your plant's ability to weather risk and to weather pathogens, and then your overall rating. So I look forward to receiving these on ours, but this is, this is just some nice interpretation that we appreciate as sort of NRCS destined data and tools. But to get down to brass tacks here, the product that we used is Environoc 401. It's an all organic plant stimulant. Now, there are a lot of biostimulants and biologicals on the market. We had to pick one. They all have different claims to fame and what they're trying to do. This one in particular contains 28 unique bacteria strains designed to release phosphorus, ammoniify nitrogen, fix atmospheric nitrogen. So a lot of great promises, and if they hold true, could be game changers. And that's why we always have producers asking us about them. They encourage natural plant hormone production and root development, and they are in a liquid formulation. So when we were trying to get this stuff on the ground, I asked, all right, how can we spray it? What if we were doing this in a conventional sprayer? It can go right into your tank with your anhydrous, your early season fertilizer, your herbicide, fungicide that happens at that early season. And I like to give you an idea too of the timing. So in Missouri, we got this on the ground April 30th, but there is some flexibility in that. Again, if you're thinking of it as sort of nurturing this symbiotic relationship, you can get it on, anytime the soil is there, but pre-emergence. So we hit it right between post-planting, pre-emergence in that late April time for our corn. And the application rate is 16 ounces per acre, just to give you an idea of how much is going on at that time. So I'm leaving you with a cliffhanger, and I'll see you next time, but I am happy to take any questions. This was a big team, a lot of partnerships, a lot of moving parts and hands helping us. So I will answer questions as I can, or I'll refer you to the right person. Yeah.
Crop rotation, and could you tell us something more about the tile and drainage situation?
Oh, the lack of tile drain situation. Yeah, so they had some tile that was not effective. It wasn't sloped right or anything. So the tile drainage is completely out of this study design. We are all runoff overland flow based. And then it's a corn soybean rotation. So these fields will all flip flop in this 2025 season, and we'll be tackling that as we go. And then the hope is that we can receive funding to continue this so we can have replicates throughout time. Thanks.
Picture of that there.
There was, yep. And then it terminated prior to application here. But yes, cover crop on all four, actually. Yep. Excellent. Thank you. Any others? All right. Thanks.
It was fun. All right. Our next speaker is Cole Dickerson.
Thanks, Victoria. Hey, everyone. Thanks for being here. I'm Cole Dickerson. I'm the Water Rangers Program Manager at SRAP, or Socially Responsible Agriculture Project. It's a mouthful, so we call it SRAP. I'm here to talk about mapping CAFOs, or concentrated animal feeding operations. We have a really cool custom GIS mapping platform on our website that I'll be going through today. And I know it'll be helpful for a lot of people at the conference, a lot of you all, to improve water monitoring, to improve advocacy. It can be used in research. We'll talk about all that fun stuff. So I'll tell you a little bit about our organization, go through a quick regional overview, and then do some demonstrations in the portal. So the Socially Responsible Agriculture Project, we've been around for over 20 years. We work primarily to serve rural communities, help them if they're impacted by industrial livestock facilities. And more broadly, we're advocating for a food system that's built on regenerative practices, justice, democracy, and resilience. And a note that I want to make here is we work with a lot of communities. We only work with them if they request our help. We don't go into a community if we're not wanted. And, we're not in the business of causing any trouble. We're here really to support communities, be an educational resource and a guide on how to deal with a lot of the challenges that these facilities pose. So why we're at this conference, we have a program based on water. So there I am with my boss, Lynn Henning. He's the director of our Water Rangers program. We work to train communities in water monitoring. So we have a lot of trainings. We do general trainings, private trainings. We work across the nation. We do a lot of our work in the upper Midwest, a lot of our work in Wisconsin. So this is a great conference for us to present at. And I'll note if anyone has questions about any of our work, I'm happy to answer anything, not just regarding the portal. In case anyone maybe isn't as familiar with CAFOs, here's just a quick table that has some definitions for the facilities. When I mention a CAFO, again, that's concentrated animal feeding operation. I'm referring to a large CAFO. That's 1,000 or more animal units. Don't have time to get into it, but basically an animal unit is equal to one beef cow. You can see what the other numbers correspond to with other common livestock animals. And so now we can get into talking about CAFOs in Wisconsin. Again, we do work across the country, but I figured we'd focus on this state since we're here. There are over 340 facilities in the state that are large CAFO status. You can see on this map, you visualize where they are. There's a big concentration right around where we're at in Green Bay. So those are the counties around Green Bay have the highest concentration of the facilities in the state. And when we talk about these facilities, we need to understand that they do have an impact in a lot of cases. They deal with an incredible amount of waste that has to be managed. That waste is not put through any sort of process like human waste is to make sure that it is as clean as possible. It's just put out into the environment. A lot of times that can cause environmental damage, such as eutrophication. There are a lot of pathogens and toxic chemicals in this waste that can, get in human systems based if they're recreating, if they're swimming, if they're drinking the water, etc. And then we also know that a lot of these facilities are sited in under-resourced, underserved communities, and there's also a correlation between a facility in an area and decreasing property values, and there's also an animal welfare piece as well. So we're in Green Bay. I figured we could take a look at the region. We understand, talking about CAFOs is a little bit of a taboo subject here, but we understand, there are lots of impacts from them. So we need to talk about them, have an open conversation about them. The three counties that encompass Green Bay and surround it, Brown, Kewaunee, and Manitowoc County, they house an incredible number of animals. Here in this table, you can see in Brown County, there are 22 facilities, just under 50,000 dairy cows. Kewaunee, there are fewer CAFOs, but even more animals. And then in Manitowoc County, there are more CAFOs, about 49,000 dairy cows. Altogether, every day, these facilities on average, this is an estimate based on the University of Wisconsin, Madison numbers, they produce about 2.7 million gallons of waste every day. That is the equivalent to 4 Olympic-sized swimming pools. So it's an immense amount of waste that is untreated and has to be managed in some way. So that gives you a perspective of what's being produced. And to give you an idea, I think in Brown County, there are around 270,000 people, but in the rural communities, a lot of these animals outnumber the people in the communities up to like 5 to 1. So here's a quick visualization of where those facilities are located. You can see on the right side of the screen, there are county borders, so you can see where those facilities are in each of the counties that I just mentioned. These are maps that are coming from our GIS portal, so that's what I wanted to talk with you all about today. We want to make sure people understand this resource is available. It's free. It has a lot of really good information. We created it to help communities understand the impact that these facilities have and really to centralize a ton of publicly available information. We currently have a national map and then 13 individual state maps. We're constantly updating those and adding more state maps. I'll have a QR code at the end of this if people want to look at it on their phone. Here's a link as well. It's not optimized for cell use. It's best on web, but in case you want to go and look at any of the information. Some ways I figured I'd mention that it's helpful in any of your all's work. It can be very helpful to determine what's around water monitoring sites. It can be very helpful for general research. We work with a lot of researchers using this platform. I'll go through a lot of the layers that we have, and you'll see how it can be useful. And then in general advocacy in this field as well. So I'm going to go through three scenarios quickly. I'll try and be as quick as possible. I'll go through a lot of the functionality of this platform. The first scenario that I have is maybe there's a community group or a community organization that monitors in an area, and they want to determine what CAFOs, impaired waterways, and field application sites are within a 5-mile radius of one of their sampling sites. So I just have screenshots. I'm hoping to upload a video of me with screen share, but I think this gives us a good idea of what this platform looks like. So when you go to our site, you can click on individual state maps. We do have one for Wisconsin, so we'll be looking primarily at that. You can see some of the other individual state maps that we have there. The layers that I included for this scenario, we have Wisconsin CAFOs from the DNR. We have all of the field boundary sites that are included in these CAFO permits in the nutrient management plans, which is really, really great information to have in Wisconsin. And then I also have impaired waterways. So what we have is a really cool feature called What's Near Me. It's just next to the Wisconsin map layers there. If you click on that, you can pinpoint a location on the map and identify a certain distance you want for a radius that creates an area and identifies all the features in that area. So what's really cool is we can do that. So in this case, we did a 5-mile radius, and we can see all the facilities that are in that area just by expanding the menu that's on the left-hand side. And you can see the specific dairies, in this case, specific facilities that are located in that region. And if we want to find out more information about them, we can either click on the triangle on the map, or we can click on the facility name in the left menu. And a pop-out window comes out. This is all, like I said, publicly available information from the Wisconsin DNR. I would love to be able to scroll down, but you can see some of the information that we include here. What's really cool is we have the animal unit number. So there's 1,600 animal units at this dairy. You can look at their facility ID and permit number and get those permit documents on the DNR website if you would like. If we want to see field application sites, which I think is one of the best features of our map, then you just go to the CAFO field boundaries. There are 640 field boundaries within this 5-mile radius. So if anyone's unfamiliar, a lot of what they do with this waste is spread it on fields around the region around the facility. And we know where they spread based on what they include in their nutrient management plan. And we're fortunate that the Wisconsin DNR has that information and we're able to use it. So if we want to look at any particular field, we can. Similarly, you can click on the feature on the map or on the left-hand side of the menu and pop out. You can see what facility has included that field in their nutrient management plan. So what facility is spreading there, and a bunch of other information, their field names, so you can cross-reference that in their NMP, etc. And then you can also look at impaired waterways. We use like the EPA 303D list. If you want to find more information about any particular waterway, here you can see that you can do that. So there are 6 in this area. If we want to open a pop-out window, we can. So School Creek, and it's impaired for phosphorus. That is information that we can look at. We just updated this so you can look at the EPA My Waters database from a link in this pop-out window, which is really helpful. So moving on to our next scenario, say like a volunteer monitor wants to alert the closest tribe of results from their testing. We've been fortunate enough at SRAP to work with an Indigenous consultant, Good Sky Guidance, in the last year, just to review like our policies and work and help us engage with tribes, because we want our support to be accessible to everyone. And one thing that we've noted is how important it is to alert tribes of any important environmental data. Historically, tribes have not received that data or not timely. And so it's really important that people are doing that. Here we have a simple measurement tool on our map. We have tribal lands layers with a bunch of different tribal layers that can be useful. In this case, there's the BIA map layers, which show federally recognized tribal lands. And then we have a tribal leaders directory, those small blue dots. And you can use a measurement tool on the right-hand side of your menu that's like light green, just to see like what might be closest to your sampling site. There's just a demonstration of how that can be used. If we want to look at more information about a tribe, the Oneida Nation is the closest one to this the dark blue dot, which is in this scenario, the sampling site. So that's right next to Green Bay. You can see all the information it has, contact information, website, etc. So we try to make it as easy as possible to find that information and use it. And then the third scenario, say a researcher wants to understand demographics of a community around a biodigester. We know digesters are proliferating, and it's an important hot topic these days. Don't have time to get into it, but basically, we do have a layer on our map that shows digesters and their locations and a bunch of information about them from the AgStar database. So those are the purple dots you can see intermingled with the CAFOs. A lot of them are at dairies in this part of the country. We have another pop-out window that shows a lot of information about what the dairy the digester is affiliated with. And then when we're looking at demographic data, we have a bunch of layers. We downloaded the EJ screen data from before it was unfortunately removed from the EPA site. So we have all the metadata for that for each census tract, which I think hopefully is useful to people if people are familiar with using it and can sift through it. We also have census data. This is the National Risk Index. So you can look at a census tract, see how many people are there, see the building value, ag value, a bunch of other information. We have an ag census layer that shows the number of animal units in counties, et cetera, things like that. So this stuff can be really helpful, not only to people in advocacy, but researchers, people at the state level, all these things, since it's all this information centralized. And we do have a couple other features that I can't walk through, but you can add your own data. You can print out maps. You can use a bunch of different base maps. We have a bunch of tutorial videos to make it as easy as possible. Here's my contact information. If anyone knows of anyone who wants to learn more about CAFOs or wants to get in touch with us in any way for any reason, please send them along. I have a bunch of business cards, so I'm happy to send those out. Feel free to get in touch with me for any reason. And here's a QR code for the portal, my email again, and happy to take questions. Nice. Thanks for bearing with all that information too. I knew I had to talk quick, and I was right at 15 minutes. Sweet. Yeah.
Track how the CAFO numbers or the animal numbers change over
Yeah, we do some of that. So the question was, do we track the CAFO numbers and animal numbers over time? What I do know is in Wisconsin, over the last 25 or 20 years, the number of CAFOs has increased, I think, 125%, which is quite a jump. And they're still growing in, I think, the last 5 years, they've grown 13 or 14%. As far as the individual animal numbers, sometimes we'll do it. We have some research with digesters that tracks in Wisconsin, California, and one other state how herd sizes at CAFOs are increasing because of funding provided for digester production. So in certain cases, we are doing that. Yeah. Yeah, I'm not the digester expert on staff. I can try and answer your question, but I'm happy to connect you with someone who would know. I would think primarily it's through the IRA federal funding that's passed down through the states. I'm pretty sure that's, if anyone in the room knows, feel free to share, but I think that's the case. It's considered a climate smart practice under the NRCS and USDA, I believe. So a lot of funding for that. And I don't know how that will change. Yeah. Yeah, that's a really good question. If people downstream of a facility are finding high pollution levels, what do they do? It really depends, which is the best answer ever. There are a number of options. We provide recommendations and guidance for people in that situation. It could be if the facility is already there. In that case, there's a lot of education to be done in the community, a lot of organizing to teach people like what issues are there, what's real, what's fake about sort of the ideas people have around CAFOs and what can be done. We connect people with regulatory agencies. Some states, more action is often taken at the regulatory level than others. So if they're in a state where they're not sure if that action will be taken, then we can help figure out what other steps there are. And if there's a facility that's proposed to come in, we can help people with public comment periods, requesting public hearings, all of that stuff, engaging with those public engagement opportunities. Yeah, I think we do have some well data in there. I don't know to the full extent that we do, and I'd be happy to look and contact you with any of that information. But yeah, I'm not fully sure. I did not develop this. We have a GIS expert on staff. But I can get that information for sure. Yeah. Yeah. I have to be careful about what I say, but yeah, I mean, that's definitely, I think what a lot of advocacy organizations face when it seems like the opposition is a big industry. We definitely try and operate collaboratively, and really we just work with communities, and we provide information. We're not here we don't want to shut anyone down. That's not really what we're here for. Really, we want everyone to be operating legally and be held accountable for any pollution that they are contributing to the environment. Yeah. That's a great question. How many states have a map available on the portal? I feel like half of the questions I've been repeating back, so sorry. Yeah, yeah, 13 maps, individual state maps on the portal now. I believe we're adding several. I'm not sure exactly which ones they are, but a lot of the upper Midwest states are on there. The states that have really high CAFO numbers are the ones that we are prioritizing to put on. Last questions. Good. All right, thanks, y'all.
All right, our next speaker is Mitch Olds.
So while you're digesting your last cannolis, I got an easy to digest presentation for you. You'll have to bear with me a little bit. This was originally designed to be an intro to a whole session followed by 3 EPA presentations. So I am the beginning of a session that never happened, so I had to change the presentation a little bit as I went. So leveraging partnerships for holistic understanding of water quality in Milwaukee. And that irony is not lost on me that I'm talking about the benefits of partnerships and all my partners have left me today. But it's a really great project. We've been partners for 25 plus years now for this one particular project. And I'm going to give you a lot of context for what MMSD is, Milwaukee Metropolitan Sewerage District, and why we're doing all the things that we're doing when we are a sewerage district by name. So, like I said, water reclamation is what we do. But we have a vision of a healthier, cleaner, and resilient region. And to accomplish that, we have to do more than just treat wastewater that comes to us. There are 2 main things that we are tasked with doing by our DNR, and that's the water reclamation and then flood management. If you really think about those 2 things, of course, you got to treat wastewater. Of course, you got to deal with flood water before it gets in people's basements. But why do we do those things? Public health and environmental health. Those are the big overarching ideas here. We're not necessarily tasked with that, but that's why we do the things we do. So when I'm talking about water quality coming up, biological monitoring, all those different things, it really comes out of these 2 ideas of why we're doing all of this. So who do we serve? What does this look like, people that aren't from Milwaukee or Wisconsin? We are 1.1 million customers in 29 municipalities. We're not a city government. We're not county government. We're a state chartered agency, which basically just means we're kind of a local government governed by a commission. So we're not answerable to any one in particular city or unit above us besides the state. We cover 423 square mile planning area. And while there are plenty of places that have bigger operations than us, more customers, we only have 2 treatment plants, which each do at its peak probably about 330 million gallons a day. On a typical dry day, more like 60 each. So we're treating about 120, 130 million gallons a day on a normal dry day. And I should note, we're one of 2 combined sewer systems. So we get rainwater that comes with the system too. There's 2 of them in the state, and there's about 700 in the nation that fall underneath the same permitting that we do of combined sewers and where the water's coming from. The EPA states that these 700 different water treatment facilities need to treat 85% of all the water that comes to them. The rest of that would be combined sewer overflows into the rivers that are surrounding them. We treat 98.6 the last time I checked. It just updated in January. What's really cool is this was 98.5% when I started making this. We updated it to 0.6. Seems like a really small number, but in the context of treating 100 million gallons or more every single day, that 0.1% difference is billions of gallons of water. So it's pretty cool to see that number continue to go up as I incorporate that slide into all my presentations I give. So right now I am a research associate. I manage a lot of environmental research. In a past life, I was the captain of a research vessel for MMSD. So if you see a few photos of boats in here, that's why. I can't miss an opportunity to put some boats in my presentations. But really, our freshwater resource monitoring program is the backbone of the research that we do. We're getting water quality of about 41 different analytes that we're testing for, heavy metals, nutrients, microbiology, from about 100 different sites in our entire area that you saw before. So we're trying to gauge what impact are we having on our area waters and what's coming to us from upstream. And we have that boat that goes out onto Lake Michigan and kind of gets the reference of what's happening on Lake Michigan. So, like I said, there's my boat. That's the MMSD Pelagos. It's a 43-foot, 32 gross ton boat. It's been with us for 35 years, born approximately the same time I was. It was destined to be. But we take that out in Lake Michigan in all weather, and I'll show you some peeks of what that looks like. I know what you're visualizing right now is a nice July day, a really oligotrophic Lake Michigan, and me hanging out on a chair on the back. It's not always the case. We sample year round, so I'll show you that. But why do we monitor? Why do we do all these things? Why are we getting all this environmental data? Mitch, you just told me you treat wastewater and you deal with floodwater. Why are you getting all this water quality information? We're required by state. Our permit says we have to do this sampling to see what our impact is. We're also doing this to get a current status of the waterways. We actually have about 50 years of data now that we're working with, long before I started there. And being able to share that with the various universities, with other like nonprofit organizations that are there, the federal government, being able to share all that data and really help keep their projects moving forward and stretch their dollars a little bit further. And then additionally, we have a whole crew of people in a boat and vans on bridges, being the eyes and ears of what's going on. So we've been out there before and seen some silt fences breaking loose on construction sites, been able to fix that before a whole bank gives way. We've seen some barrels, quote unquote, fall out of a truck and land in the river and be able to get those out of the water before they burst. So being out and seeing what's going on in the community is just really an asset of trying to fix problems before they really start. We're not the police. We're not doing regulation on these people. We're just trying to help make sure our waterways are healthy and help them make them that way. So when do we monitor? That's what I was talking about. Those July days, those are really nice days. You can see it's not always that way. We monitor year round about 2 or 3 times a week. My job was about 50% in the field, 50% at the computer, doing all the interpretation of that data, and all weather conditions. So if we had a CSO, a combined sewer overflow, we had to go out. As you can imagine, if there was a CSO, it wasn't great weather. But you'll see on the left, she's actually being blown over by the wind that's going over the boat right now. That's why she's sitting back like that. And on the right side, it's one of my friends there, with a pile of samplers kind of sitting next to him as they freeze up and he's unable to use them, eventually just going for the bucket and trying to get what he could out of the river. So when it's 0 degrees outside, it's not easy to sample liquid water. So where? These are those almost 100 sites. Give you an idea. They're spread way out. They go far enough out into Lake Michigan that you can't see shore anymore, and kind of covering everything to the north, to the south of us, what's coming to us before we're kind of interacting with the water ourselves. So we get an idea of what's happening in the background and kind of gauge what we're doing, what our impact is, how that's all working together. And then what do we monitor for? This is just a list if anyone's interested in what we sample for. Like I said, metals, nutrients, biological, but we're also getting a lot of that sensor data and any of the normal conventional stuff, BODs, that kind of thing. So you do all that sampling. What does it all mean? How is water quality doing in Milwaukee? That's a loaded question. That is well, it depends on what you think is important. It really is a subjective question of what do you value? Do you want to be sitting in the bottom right on your boat taking Instagram photos? Because then maybe you want the really clear oligotrophic water. If you're in it for catching game fish or having sturgeon spawn or wildlife, you might want different water quality, and those ideas can kind of compete with each other. Generally, we've done a really good job of limiting the amount of bacteria in the water. We're way down from what we were 20, 30 years ago. Some things we still struggle with. We use road salt in Milwaukee, and those chloride values can get really, really high. Not quoting any numbers here, but they can get toxic for organisms, acute toxicity in some cases. So even out in Lake Michigan, outside the harbor, we're even seeing steady increase year after year. Very low number still, but the trend is going a direction we don't want it to go. So all those things, water quality parameters aren't going to tell you everything you want to know to answer the questions of how is water quality doing. We also got to think about biological testing, geomorphology, a ton of other things that don't really fall underneath a smaller local government. We can't staff for those levels. And so what we do are partner with our various universities, federal government, other agencies to try to coordinate with each other and make sure we're not duplicating work, first of all, but also kind of taking advantage of special skill sets, special equipment. If someone needs a boat, we have a boat. You've seen pictures of it now. And going out there. So what we started was called the Watercourse Corridor Study. This is just one of the things we're going to talk about. But established in 2000, so about 25 years. And what they do, it's USGS, it's our USGS partners. They're coming out and doing all that fish shocking, looking for zooplankton, phytoplankton, doing the geomorphology assessments, the things that USGS are really good at doing. And I will say the last couple of months has made me very acutely aware of how important it is to kind of do some cost sharing too, of don't have all your dollars coming from one place. We're still able to move ahead even if one arm of the partnership is having a harder time than the other at the moment. And that can swing back and forth throughout the years, but having the partnerships, having the people, having those relationships really help us coordinate what we're doing and get a better product out of the whole thing without having to remake the wheel, reinvent the wheel, redo work that the other one's already doing. We're just not aware of it. It kind of forces that interaction so we're all aware of what's happening and can kind of build off that, leverage cost sharing for it. So if you guys are in the Whova app, I haven't done it yet, but I will put a link in there after this talk, just so you can go and see what's in there. What I find more than anything are all of that data we're collecting, the DO of Lake Michigan, what's the total suspended solids. That doesn't mean a lot to the general public. Even if I'm telling you, that's a really good number, that doesn't mean a lot. When I show them this of a picture of a salmon in one of the rivers, oh my gosh, salmon can live here. That means everything to them. So all that work we're doing is really great. I would say the biological component to it is the most compelling evidence for the public. And then when we find something interesting, we can go through and look at all that water quality data and try to tease out what's allowing that to happen, what allows that fish to get there. There's also some issues with in the 1950s, 1960s, that flood management that I talked about earlier. The idea was we should straighten all the streams, line them all with concrete, and make the water move as fast as possible. It won't go in your basement if it's not there at all. Now we're walking that back and saying that wasn't the best idea. Trying to get some sinuosity to the streams. And I say restore instead of naturalize because it's never going to be natural. One of the rivers that we manage, the three big rivers in the area, the Kinnickinnick, I believe is 98% urbanized for its watershed. That's not easy to shoehorn in a natural stream into that. So we do what we can. It's better than it was. It provides habitat that wasn't there before. But when we're doing our fish IBIs, our indices, sometimes we had spots where native minnows could survive. We do this restoration, bigger fish that you want to be there come up and there's some evidence of them eating all the minnows. So even those indices can kind of be deceiving in the very beginning of we've had them go down after a restoration project happened. But the hope is they will continue to grow up. But One of the coolest things with USGS is the publications are all open source. No one needs to pay to go see what we're doing with your tax dollars. We keep that all open source. The link I put on there will show you what all the publications are associated with this 25-year project. You can read all of that. You can see all the different fish cameras that we have. Continuous data is all available for whatever project you guys want to do. It's all there. It's all available to anyone that wants to look. Another project that we do that kind of spun off the corridor study was dealing with litter in an urban area. That happens. It's when I started, I came from this area, Fox Valley. I went to Stevens Point, was kind of the center of the state, a very rural area. And this is my first time working in a really urban area. And I was surprised at how many Swisher Sweet wrappers I would find after a rainstorm. For whatever reason, that was the big one. So trying to find ways to deal with the litter. We do have a river skimmer. If you see an Aquarius as the exhibit hall, they make those. A lot of those pictures are from Milwaukee Harbor. One of our boats is actually on there. That does a really good job of picking up some of the larger pieces of litter. The Great Bubble Barrier is actually something that is a stationary object. It makes a bubble curtain. If you've seen areas that freeze over, they put bubbles by the boats to keep the ice away. A similar thing. So we're going to have it angled in the stream, the Menominee River coming out of the western suburbs into Milwaukee. From left to right is the flow. We'll have a curtain of bubbles there that will funnel all of the litter coming downstream into that area where that little pin is, the Ember Lane Public Boat Launch, where we have a collection facility set up there. So the bubbles will actually impact the litter as it comes down, moving it along into a bin that can then be picked up and removed. So trying to get some of those smaller pieces out before they actually make it into the estuary, the harbor, the lake. Our hope is getting it out as early as possible. We'll keep it from turning into microplastics, nanoplastics, and PFAS issues, and everything else that we're going to find out about in 10 more years. It's a really great project, and we're doing a lot of microplastic sampling along with it through our partnerships. One of the cool things about it is it can be tailored to work in different flow conditions. That's heavily in the estuary area. It actually has a lot of lake impact where occasionally flows can reverse. We have it set so that it can shut down during that stage where the flow is going the wrong direction. And it'll shut down too when the flow is just so high in a storm that we can't have the bubbles compete with it. But our modeling shows about 99.5% of the time it will be on, grabbing garbage before it makes it into the lake. And that's a really great thing to do. And a shout out to Meijer Grocery Store. They are considering covering portions of that through their foundation. They have some going in Michigan too, I believe. So it'll be a really great study. First one ever built in the US. And hopefully more communities can use it if that indeed does work. So if you ignored everything I said about water quality and all the things we're sampling and what's going on, this is a picture from the boat. You can see the bow in there. But I'm looking downstream towards the lake. And what you see there are a lot of apartments, restaurants, stores, gyms. Without looking at how many fish are in the water, without looking at what the DO is of the water, the heavy metals in the water, you can see there's development happening. What you're looking at is $1 billion with a B dollars of investment along the waterfront. 30 years ago, no one wanted to be near the water. The places you're looking at were not places you wanted to go. They were bad, stinky, unsightly places. Now it's where you want to have your fancy table at a restaurant sitting on top of it on the Riverwalk right next to you. So without really knowing anything about water quality, if you're a person in the public, you can see things are changing. And with that, one more picture of my boat. I'll take any questions you guys have about partnerships. Yeah, so how do you create the bubbles for the bubble barrier? Part of that was that boat launch is owned by the city. And so we have facility there, an area where we're able to build our compressor to put there, and it goes through perforated hose that's anchored to the bottom of the stream and bubbles up in a curtain from the bottom to the top. Actually, one thing to point out here too, at the very top of the screen, that really big building, that's a recycling facility that handles recycling for about 500,000 people. As you can imagine, not every single bottle and wrapper actually makes it into the facility and can blow away. The river's right next to it. So it's a great spot to kind of catch some things as they enter the water. Great. Yeah.
Great presentation, Mitch. You talked a little bit about some of the stream restoration stuff you're doing.
Yeah.
I guess, can you expand, is MMSD, are you guys investing in some of the natural infrastructure that's left in the basin at all? You know, remaining natural land cover, that sort of thing, or?
Yeah.
Yeah.
So we're permitted by the DNR. I'm going to take one step back from your question of what are we investing in for the natural infrastructure that goes along with this. When we're talking about the stream restorations, our goal in the entire area is to manage 740 million gallons of water in a rainstorm. That comes through green infrastructure, that comes through just stormwater, gray infrastructure too, but green infrastructure being out there to kind of catch that first flush, that equates to about the first inch of rain covering our entire area. So when we're doing the stream restorations, we're really thinking about how do we hold those banks back to allow a bigger floodplain? How do we get natives next to it? How do we allow that stream to store more of the flow without having to rush it back and actually create human hazards that almost annually seem to have some injuries that happen from just the flow of water. It's so flashy. It's almost like you're in Zion or something and there's a flash flood happening of you look at the grass and it's a wall of water that goes from inches to feet in a matter of minutes. So taking care of some of that is really what's important to us, and creating those floodplains is what really allows us to spread that water out and not have those gigantic flows that come through. Yeah. Thanks, Aaron. Great.
All right, our final speaker today is Leanne Aston.
Good afternoon, everyone. Thanks for hanging in there. I am also a remnant of a session that was not to be. So I appreciate your coming. I am an ecologist with Fairfax County, Virginia's Stormwater Management Division. In this presentation, I'll discuss who and where we, meaning Fairfax County, are or is, why we monitor, what we've learned from 20 plus years of stream monitoring. Actually, it's closer to 25 at this point, and why it matters. So who we are is Fairfax County. We are in Northern Virginia, a highly densely developed suburb of Washington, D.C. And where we are is the Chesapeake Bay watershed in the Mid-Atlantic. Now, Fairfax's Stormwater Planning Division conducts stream monitoring to meet the county's regulatory requirements. In the Bay watershed, local governments must comply with layers of federal standards, regional goals, state regulations, and local ordinances to meet water quality and ecological health requirements. Obviously, at the top of the pyramid is the EPA, the Federal Clean Water Act, and the National Pollutant Discharge Elimination System Permit Program. Now, EPA's Mid-Atlantic Region 3 tracks and enforces Baywide and local TMDLs, but the required reductions are set by the Chesapeake Bay Program, which is a regional partnership of multiple federal agencies, state agencies, local governments, and others that directs and conducts the restoration of the bay and its tributaries. Their Science and Technical Advisory Committee, or STAC, sets the ratios, delivery rates, and removal efficiencies of BMPs for bay-wide pollutants of concern, which are basically nitrogen, phosphorus, and sediment. Virginia's state water control law, the Chesapeake Bay Act, and associated management regulations and numeric criteria form the basis for the Virginia Pollutant Discharge Elimination System and the MS4 permit program, which is administered by the Department of Environmental Quality. Now, stream monitoring by local governments, if I may say so, plays a critical role in water resource protection and watershed planning, providing baseline data, assessing stream health, identifying degradation, and assessing protection and restoration activities. Now, the goal of Fairfax County codes like the Chesapeake Bay Preservation Ordinance and others are there to protect high-quality waters, prevent pollution, restore waters, and limit development in resource protection areas. The MS4, and we do have a phase 1 permit, is the whole county's permit, but stormwater planning's comprehensive monitoring program is an important component. Biological assessments inform multiple MS4 program elements, particularly stormwater management and stream restorations, which I'll talk about more in a moment. And of course, we produce an annual MS4 report to the Board of Supervisors and the state summarizing accomplishments. Now, county ecologists conduct annual biomonitoring of streams. Actually, that circle is in the wrong place. It should be around the regulatory bullet. But we go beyond the 5 minimum required sites, sampling over 140 sites a year. I should say collecting over 140 samples a year, because some of these are trend sites and we do some sampling in spring as well as fall. Our probabilistic site selection is weighted by drainage area. Obviously, there are more lower order than higher order streams in the county, and geophysical region. Benthic macroinvertebrates, physical habitat, including geomorph, and water quality are sampled using modified RBP protocols. Our benthic index of biotic integrity, BIBI heretofore, is calibrated for Northern Virginia and compares bugs in sampled streams with least impacted reference sites. BIBI metrics and scores are calculated from a 200 count subsample of organisms ID to genus. I mention this because it will be important later. The western third of the county is in a geophysical region called the Culpeper Basin, which is the largest of Virginia's Mesozoic or Triassic basins. And these are basically sedimentary basins formed in the Triassic period by the breakup of the Pangean supercontinent, basically ancient lakes. The topography is mostly low relief with Jurassic era volcanic intrusions in the forms of dikes or sills. Bedrocks are siltstone, sandstone, shales, conglomerates, and diabase, all of which crumble more easily than the crystalline rocks of the Piedmont. And the soils derived from these parent materials are shallow, not very permeable, and highly erodible. Under some classifications like level 3 ecoregions and physiographic provinces, the Culpeper Basin is considered part of the Piedmont. But the geology and soils and landform all differ. Piedmont bedrocks are deeply weathered igneous and metamorphic rock versus sedimentary rocks with igneous intrusions in the Triassic. Piedmont soils are deep, up to 20 meters to bedrock, more permeable, more acidic, versus shallow depth to bedrock, not very permeable and more or less basic soils. And Piedmont landform is mostly gently rolling versus low relief, pretty flat, except for those diabase dikes. All of these influence stream physical, chemical, and biological characteristics. So I'm going to quickly run through differences we've identified between Piedmont and Triassic reference quality streams. By the way, our Triassic reference streams are all second order streams with drainage areas less than a square mile. Again, there are not many higher order, larger order Triassic streams in our area. So for this analysis, we excluded larger Piedmont reference sites for these analyses to compare apples to apples. In the next few slides, Piedmont's going to be on the left and Triassic is going to be on the right. So Piedmont stream valleys, generally moderate slope versus low gradient, although reach slope can vary. Piedmont streams have sinuous, usually single channels of varying depths versus broadly meandering to nearly straight, shallow, and sometimes braided channels. Piedmont streams have moderate flows, usually sustained by base flow during dry periods, versus sluggish flows that may periodically dry up. Piedmont floodplains are less broad versus very broad floodplains, more frequently accessed, and a lower depth to bank full. Bed materials in Piedmont streams, rounded gravel and cobbles of granitic and other crystalline rocks versus, you see on the right, these flagstone-like channers of siltstone or sandstone that gradually fragment to fine gravels. We also see erratics from limestone conglomerate and or diabase, sometimes as boulders. If you look at the D50s, the particle size classes appear similar. Both types have cobble and gravel, but they're not exactly equivalent. On the right is what passes for cobble and gravel in a typical Triassic stream. By the way, water pennies love these stuff. Riparian areas in the Piedmont are uplandy with highly acidic soils versus wetlandy with alkaline alluvial soils. Putting it all together with the Rosgan Key Piedmont data point pretty clearly to an E channel. While Triassic classification is less clear, some indicates point to a B, a C, or even a D channel. Food for thought, almost all of our stream restoration consultants design their restorations to a C channel. Moving on to water chemistry, erodible soils from ancient lakes equals more dissolved solids equals higher specific conductance in Triassic reference streams. That's on the left. We see an average of about 170 to 190 microsiemens compared to around 50 for our Piedmont reference sites. Now, this higher conductivity is driven by higher natural background phosphorus in Triassic soils. Remember, ancient lakes. Fairfax Stormwater has a partnership with USGS using a countywide gauge network to monitor streams with flashy hydrology. So the bar chart on the right is not reference site data, but even so, mean phosphorus concentrations average 2 to 3 times higher at Triassic gauges, and a P higher than 0.05 parts per million is considered high. On to biological differences, starting with riparian vegetation, NMDS and principal components analyses of plant data from streamside plots both show good separation between Triassic and Piedmont plant communities. Generally speaking, Triassic riparian areas have more species and more non-native invasives. They're wetter, more frequently disturbed, more herbs, less overstory. But even when we omit invasives and ambiguous taxa, we still see differences in native plants. On the right are the top 10 natives for each region, and the Triassic communities dominated by hackberry, spicebush, pawpaw, and hickory, to name a few. In the Piedmont, it's tulip tree, beech, partridgeberry, and lady fern, among others. Very different forest cover. This is very helpful for planting palettes and Triassic stream restorations. So on to the bugs, we did multiple analyses of benthic macroinvertebrate community similarity. As you see here, the clusters are distinct, Triassic streams all on the left, those first 3 leftmost branches, and Piedmont on the right. This is an NMDS plot of the same. You can see the decent ordination between Piedmont and Triassic sites, but the 50% similarity circles reveal distinct groupings based on location, on geology. The Piedmont sites cluster fairly tightly with some separation of smaller versus larger drainages, but they're just all kind of in a group there, while we see high site fidelity in the Triassic sites. This tells us we have a good selection of Triassic reference sites accompanying geophysical variation. And it also suggests benthic diversity across Triassic reference streams is greater than in the Piedmont. That's kind of cool. Well, who's deriving this diversity? These guys here. We've got the good bugs, mayflies, stoneflies, and caddisflies. There are other good bugs and some, that are maybe a little less interesting, but these are the ones that exert the most pull on the axis. This is a box and whisker plot of Bibby scores, Triassic versus small drainage Piedmont reference streams across the monitoring interval of 10 plus years. The scoring range of our Bibby is between 0 and 100. This starts at 50, so don't let that fool you. Yes, Triassic basin streams generally score lower than the Piedmont, but I want to point out that a mean score of 78 is a high good on our Bibby, and above 80 is excellent. So not bad, just different. As mentioned, bioassessments inform multiple MS4 program elements. We get a lot of mileage out of this data. Management plans for the county's 30 watersheds. Stream restoration projects have evolved, especially in the Triassic, but everywhere. Less rock, more wood, more connection, reduced sinuosity, oxbows, lighter touch. Basically, protect what is good. We have a better idea of what good looks like physically in the Triassic. And, assessing functional lift of our restorations using the Bibby. Again, we have a better idea of what good looks like. Impacts for stormwater management, BMPs and BMP retrofits. Basically, some stormwater practices and BMPs just don't function well in Triassic soils. They're not very pervious. Our code inspectors are better able to identify illicit discharges to Triassic streams and issue corrective actions. No, it is not just red water, that's sediment. Environmental planners use this information in the construction plan submission and the rezoning phases to recommend alternative stormwater controls that de-emphasize infiltration and or require geotech testing. Now, the index scores for those 5 required MS4 sites, none of the prom-ons, are what we're supposed to submit to the state of Virginia. Index scores are calculated using the Virginia Stream Condition Index, or VSCI, not our Bibby, for the annual report to the state. But there's no permit-specific benchmarks or targets. Just, are we doing what the permit says we're supposed to be doing? Are we monitoring? Well, yeah. We do submit our Fairfax raw data for all stream sites to the Department of Wildlife Resources for our scientific collections permit, and DEQ gets it from them. And again, for the VSCI, things are boiled down a bit. The subsamples are rarefied from 200 count to 110 individuals and aggregated from genus to family. Now, DEQ stratifies their stream site selection by level 3 ecoregions, but the VSCI assessment uses 2 physiographic provinces, tidal and everything else in the state, mountains and all. I should mention that once everything is distilled like this, even our reference sites fail the VSCI. Also, DEQ doesn't sample headwater streams in part of their statewide monitoring. This is a weighting issue as well as scalar. And the state water quality standards don't consider geophysical factors for physiochemical and biological impairments. So what we end up with is reduced sample size, loss of precision, coarser levels of taxonomic resolution, and attendant effects on metrics and index scores, which produces an incomplete picture of actual biodiversity as well as ecological condition. We also share our data with the Bay program for the Chesapeake Bibby, the Baywide Stream Health Index, which aggregates data from multiple sources in the watershed. They stratify their sites by HUC 12 bioregions. In Fairfax, we have the Southeast Plains, Piedmont, and Lower Northern Piedmont. Again, the IDs are collapsed to family, calculate metrics and index, used to assess relative condition of streams compared to sites in the same bioregion, which may be more rural, less urban than Fairfax County. The Chesapeake Bibby consistently rates all Northern Virginia streams as very poor. This is what decision makers and the public see. It's not a great look. We also communicate our information to STAC, and some pollutant delivery and removal rates were updated in 2020, based in part on Fairfax County's input. So that was a positive step. I do want to draw particular attention to the 2023 STAC report, which evaluated why progress toward meeting Bay TMDL and water quality standards has been slower than expected. That report recommended enhanced monitoring at finer scales. So EPA uses level 3 and 4 subregions, level 3 ecoregions, level 4 subregions for integrated assessments and regulatory oversight. And we have a great relationship with the Region 3 aquatic biologists. They are aware of the differences between Triassic subregions and the rest of the Piedmont. In fact, Region 3 used our data to account for unique characteristics for stressor identification for a conductivity TMDL and an impaired Triassic stream. Hopefully, this will continue in the future. So the implications of scale, obviously aggregating bioassessment information from different sources can provide broad scale assessments, but it can also be problematic. You're taking apples, bananas, and oranges and turning them into smoothies. That can be messy. Broader scale assessments can overlook issues of representativeness. Local landform and land use is insignificant at broader scales, but highly significant at the local scale. When you widen out like this, you have a wider range of available reference sites, again, some of which are more rural, which are used to define reference conditions and set expectations for your metrics and index. And aggregating biological data using coarser levels of taxonomic resolution may also aggregate traits like tolerance values, feeding group, and habit, and those related metrics differently, which affects bioassessment index scores. Obviously, IDs to genus are preferable. And regulators tend to reference these broader scale assessments when setting policies and regulations, evaluating compliance, and assessing outcomes of management actions. But using indices or models calibrated at broader scales to determine regulatory compliance or assess ecological lift obscures condition assessments and restoration progress. Final thoughts, Triassic streams, not bad, just different physically, chemically, and biologically. These differences have implications for bioassessments, stormwater management, regulatory requirements, and stream restorations. And scale matters. Understanding your watershed matters. We were kind of at a moment here, again, in Region 3 and the STAC program, Bay program STAC recognize the need for finer scale assessments to measure Bay progress. Local, state, and regional partnerships are key to that. But with the current federal climate, it's going to be mostly up to local governments to decide what level of monitoring they're comfortable with to protect water quality and ecological health. Thank you. I'll gladly take your questions.
Any coordination based on temperature?
Shorter answer is no. Temperature is temperature and by association dissolved oxygen are transient. We take water temperature when we are out in the field with a YSI meter. The gauge sites collect temperature at the time of sampling, but we haven't divided them into temperature regimes.
It seems to be that small drainage areas with that much water in them are probably fed by groundwater to some extent, maybe.
Some, yes. Actually, two of our Triassic reference sites are spring fed.
My follow-up question then is, do you think that there's representation of those drainage areas in any of your Chesapeake something or your Bibby?
In the Chesapeake, I don't know all the data that they compile to calculate the Chesapeake scores. But even if you're just looking at the 3 bioregions of which Fairfax County is a part, those extend all the way down the central Piedmont of Virginia into very rural areas, very close to the Blue Ridge. So it's quite likely that is a concern if they're using reference sites located in those areas and comparing sites in a fairly urban area to them. I'm sorry, does that answer your question? Thank you. Any other questions? Oh, yes, please.
I noticed on your photographs that those are very small trees. And I wondered if your variety and variation in sampling might also be explained, so to speak, by areas where you have larger trees around it or more mature canopy.
Canopy or the lack of it is an issue, and I talked about that when I discussed riparian vegetation. But it's also true that Virginia has over 400 years of settlement history, and the western part of Fairfax County and pretty much all of the Culpeper Basin were extensively farmed at one time or other. A lot of the trees that have come up as those croplands went idle or pasture was abandoned are not necessarily mature trees. There's a lot of Virginia red cedar, a other plants that are, opportunistic colonizers of disturbed soils. So that's part of the problem. But our reference streams have pretty good canopy, just not, big mature broadleaf trees. Other question? Thank you.
Right. Thank you very much, everyone. That concludes this session. We now have a beverage break, which is also your final chance to make bids on the silent auction. And then the next series of concurrent sessions starts at 4 o'clock.